Okay. So, you just finished the loading on the beam, and you should say that it's not too difficult. And we have the two sets of beam. The first one are the secondary beams that are laterally based by the floor system. As I may have mentioned before, that you have to find a way to secure the floor to the beam. Okay, you cannot just place the floor on the beam and hope that it would stick. So you must provide some means to hook up the floor system with the beam, even though you may not plan to design the beam as a composite structure, which I think if you know how, you should always. So anyway, as a result, SB1, you can say SB1 is fully braced by the floor. So you can go ahead and design the SB1 right away. And you know by now that your loading condition should be like this, right? That's your tributary width. And you could just go directly and compare, and you should use ASD. Please, there's no need to do LRFD, okay? Just ASD for both columns and beams and stuff, okay? You can calculate your MA from the load that you got the last time, and you need to make sure that your MA doesn't exceed MN over factor of safety, and your MN is of course FYZX. Now from this you can calculate your required plastic section modulus, and you can enter one of my tables to pick the section with plastic section modulus that exceeds the number that you have from here. And you should check display, say a complete design. Must consider flexure, shear, and also displacement. Let's say we can use the typical one. The displacement due to live load should not exceed L over 360, or optional. The displacement deflection due to total load should not exceed L over 240. Okay, check that as well. And your SB1 should be a piece of cake. And don't worry about this one at the edge. It's just one of them and two of them here. You can just pick the one in the middle, design it, and use the same member. Okay. Now let's go to the second floor. This time you're gonna have a lot of variations. But again, like I say, a good engineer, you should look at the load, and perhaps if you want to calculate the moment and see if you have the moment closer, if say this beam has a moment closer to that beam, so you may use the same size. Okay, you can group your beam design according to the moment that you calculate from the load before you actually start your design. Okay, so let's say you can design SB3 and SB4 here. I don't know why they have 3 here. So it should be perhaps 4. So it's the same business as on the roof. This is your tributary width. You have 2 sets of different live load, and you can say that SB3 and SB4 are fully braced as well by the floor. Okay. This one should cover everything. This, if you can also try to design this one. this one, but it's part of the frame, you know. So this one is optional. Okay, so for now, you can design SB3 and SB4. All right, and there are, you know, say this one. It's yeah, it's a part of the frame, so we can ignore that one. And you may want to check this one as well. Okay, I'm sorry. I mean, you can say check this and then choose it to be the same as, you know, the other beams. Okay, please notice that these are the two beams that you can design directly. Okay, the red one, if you want to analyze the moment, it's okay, or if you want to try to pick up the section, it's okay as well. But for now, it is optional because it is part of the frame. But I would like you to be able to approximate the size, because one thing that will let you do into the design of the local failure, but you can do that later. However, it would be nice if you can do something before the midterm exam, because you can have the local failure here when the roof comes down on top of this section. Okay, so to have in order to know how to check the local failure, you need to have the section. All right. So then that's it. You know, let's go back to the roof. You see that there are beams that I haven't mentioned. This one, your SB2 here, they are not braced by the floor. The SB2 will be braced by this beam at this point alone. So that means, are we losing the connection? Perhaps. I don't see the screen that I share is updating what I write on the iPad. So I think we are losing. You guys still see the screen? Hello?
Yes, teacher.
Yes.
Here we go. Gotta redo. Yeah, it's coming. I can see that now. Huh. Okay, back to business. Okay, here we go. So you see, this line didn't show. So when you design SB2, it becomes a beam that may not be sufficiently braced. Okay, so you need another lecture before you can do that. So this time, you don't need to do SB2, just SB1. And likewise, you don't need to design this, because SB4, even though the unbraced length, which is the length between these secondary beams, are very, very, very short, but you need to know what you should probably properly do with this beam. So we will leave it for the time being. Okay. And, you know, on the second thought, let's try to do this beam as well. That's no longer optional. Okay. Do the simple analysis and try to pick the size of this beam. And let's say this beam is also, I should change the color. No, let's use the blue one. Let's say it's also laterally braced. And once you have the size of the beam, I want you to check it against the local failure. Okay, so that is the purpose. Just so that you get the opportunity to learn to check the local failure of the beam. Okay, and let's say you pick the approximate size of this red beam, you know the load from the roof. So you can pick the size of the base plate that is going to be bigger than the size of your column. Okay, and then you can proceed to use that to check the local failure of this. So let me further illustrate this problem by writing on a note. Okay. So for that particular beam, you're gonna have this. Okay. Oops, look very well. So the columns coming on, that would be your C2, right? So that is your C2. So you need to, the plate should be bigger than C2. So when you have that, you will know what your N is. Okay, and approximate the beam size. And check local failure. Okay, here. And when you have the check the local failure, just indicate whether or not bearing stiffeners are required. Now, one more thing. A good engineer would try to pick up this beam size, you know. When you approximate the beam size, it should be wide enough. Because, you know, if I draw it in this direction, look like a very good drawing at all. This is my beam, right? And you have columns coming on. So if your beam is not wide enough, you can't, you know, put the column on it. Okay, so you just make sure that it's gonna be wide enough so that, you know, it is practical. Okay, that's it. So, question?
Teacher can go up, teacher. Can...
Yeah.
Thank you.
Cheers. Okay, so is there any question? The beam design is too difficult.
On the allowable moment, what value we should plug in?
Which one?
The beam.
Allowable moment, which one?
That you highlight the red color.
Here? Well, you have you have calculated your you have calculated the loading on this beam, right? So you just analyze it, get the moment, and this is full brace as well. So you pick up the beam with a proper plastic section modulus value, and that's how you get the size. But let's say if the column here from the roof is the the H 200 by 200 series, you should have the beam that is at least like 25 centimeters wide, so that you can place the column on top of it. Okay, this is just the approximation. You have calculated the load acting on this beam, right? So just one small analysis of a simple beam, get the moment and pick up the beam size that can accommodate the column, and then check the local failure for me.
We should write the bending moment diagram of each beam or not?
Well, it's up to you, but it would be better if you do, because just to show that you have worked this moment, right?
So we can use the maximum bending moment on the
Well, of course, you have to use the maximum moment, right? Wherever it is. Are you going to use the not maximum moment, and then when you analyze, your beam is going to fail where the maximum moment occurs? Of course, we need to use the maximum.
okay.
All right. So maybe you're not that comfortable, asking questions again during the record session. So I'm gonna stop the share and stop the record and see if you're gonna ask more.